Is my screen visible to everyone? Okay, thank you. Sorry for somewhat delay. There is some network issue from my side, so I am just fixing that. Now it's done. So as we have left our discussion with remaining some two, three more naming reactions for general organic chemistry, and then we'll move towards the heterocyclic nomenclature and the naming reaction which are used to synthesize the heterocycles. Okay. Because that is also an important part for your GPAT examination, and there are many questions in NIPER also. So we will discuss that. So today's discussion, we will begin with the these reactions. Can you tell me what is the first reaction where the alkyl halide is reacting with the sodium in presence of dry ether? Remember that all the reaction which I have included, they all are very important, and almost from every reaction there are many question has been asked in previous year GPAT question paper. So type your answers in chat box, and then we will reveal the name after your answers. Which reaction is this one? Come on, guys. Fast. Answer fast. Okay, I will reveal it. I think you guys are not answering. Okay. Woods fitting. Yes. Woods and fitting. Yes. Woods and fitting. Yes, you are right. So this is Woods reaction. The above first one is a Woods reaction, and the second one is a fitting reaction. What happens in case of Woods reaction? The alkyl halide will react with the sodium. Okay. Two alkyl halides react with the two atoms of sodium in presence of dry ether, and it will produce a alkane. Okay. And remember that Woods reaction only will be applicable for alkanes. Okay. Only for the alkanes, not for the aromatic. Only for the alkyl halides. Alkyl halide when react with the sodium in presence of dry ether. Okay. When alkyl halide react with the sodium in presence of dry ether, then they will give alkane. And that reaction is known as Woods. So in case of Woods, we will include alkyl halide. While in case of fitting reaction, we will include aromatic halides or aryl halides. Okay. Aryl halides. Okay. So it will be aryl halides in case of fitting reaction. The same two sodium molecules, two atoms of sodium we will include in the reaction, and also the dry ether is same. The reagent is same, but the starting material which we are in this case we are using a aryl halide. Okay. So that is what the difference is in case of fitting reaction and Woods reaction. Here it will be you can say simple aliphatic hydrocarbon will be formed, while here in this case it will form a what is the name of this compound? The two phenyl rings are attached to each other. What is the name of this compound? What is the name? What is the name of this compound? Biphenyl. Yes. Very good. Whether this biphenyl shows the geometrical isomerism or not? Is this biphenyl show geometrical isomerism? No. Why? What is the reason behind it? You are right that it doesn't show geometrical isomerism, but why? What is the reason behind it? Which reaction is this one? And also I want to know the reason behind that why biphenyl doesn't show geometrical isomerism. Isomerism part will be covered by Payam sir. Group are not attached at ortho position. No, not the groups. But what is the actual answer is that there is a concept of yeah, free rotation around bond. No, there is no free rotation. There is a concept of you can say aerial distance. Have you guys heard about the aerial distance? So there is a concept of aerial distance. What happens that there two biphenyl rings attach with a one bond, right? So when they arranged in a plane, so they arranged in a such a way that their aerial distance is not same. Like for example, this will be explained by Payam sir in detail, but I'm just giving you an insight. So here what happens that here this distance, between these two groups, right? These are same groups on a different carbon. Then and then it will show the you can say geometrical isomerism. But this distance is known as between these two x. This distance is known as aerial distance. Okay. So this distance is known as aerial distance. There will be some lag maybe in my mouse, so that's why the name is may not appear properly, but remember it aerial distance. Okay. So it's a aerial distance. So it's a aerial distance. So that aerial distance must not be similar. Okay, it's must be different. But in case of the your biphenyls, that aerial distance is same. Okay, again I am repeating that aerial distance is same, and because of that, that biphenyl doesn't show geometrical isomerism. Now back to the topic. Which reaction is this one? Okay, so remember that simple answer that aerial distance is not same, and that's why that biphenyls doesn't show geometrical isomerism. Definitely that portion will be covered by Payam sir on optical isomerism and geometrical isomerism, but it's just correlating here, so that's why I have asked you guys. Fast, give me the answer of this. Yes, yes, it's a Woods-Fitting reaction, right? So what is the difference in here if you observe? So it's a Woods-Fitting reaction, right? What happens in case of Woods-Fitting reaction? How it is differ from Woods and Fitting reaction? So you can say it's a combination of Woods and Fitting reaction, right? Because here you are using one aryl halide and one alkyl halide. This one is a bromomethane and this one is a bromobenzene. Okay, so this one is alkyl and this one is aryl halide. While in case of Woods, both are alkyl, and in case of Fitting, both are aryl. But here we are using one aryl and one alkyl. Okay, and then they are reacting in presence of dry ether and sodium, and that will gives you a you can say alkyl combination of alkyl and aryl halide. It means that the methyl group from this bromomethane will be attached on the aromatic ring. Okay, and it form a toluene. Okay, and it forms a toluene. So remember that Woods Fitting reaction as its name indicating, right, itself. That's a combination of Woods and fitting reaction. And Woods reaction is involves the two alkyl groups. They attach to each other in presence of sodium and dry ether. And in case of fitting, we are using a two aryl halides, you can say, as the halogens are attached on the ring. Okay. Now here it is written, the name is written itself. So you guys are lucky here. Now we have discussed aldol condensation somewhere. In which reaction we have discussed aldol condensation? In which reaction? I have told you about aldol condensation in one reaction. One naming reaction. It's about something about annulation. And what is annulation? I have also told you guys that also. What is annulation? Robinson. Yes, very good, Manisha. It's a Robinson annulation. Yes, yes. So it's a Robinson annulation where we have discussed that Robinson annulation is a combination of annulation is a combination of which two naming reactions? Michael, Michael addition and aldol condensation. Yes, very good, very good. Yes, yes. So we'll discuss aldol condensation here. So what happens in case of aldol condensation? First, it is important that what are the criteria for a particular compound undergo aldol condensation. First of all, it will be shown by the first of all it will shown by the carbonyl compounds, and specifically what kind of carbonyl compounds? Mainly aldehyde and ketones. Okay, mainly it will be aldehydes and ketones will show the aldol condensation reaction. And one more important thing, which kind of aldehyde and ketone will show? Can you guys answer me? Can you give me the answer? Which kind of aldehyde and ketone? What is the requirement for aldol condensation? Because this question has been asked in previous year question paper. Which kind of dilute base is used? Yes, Manisha, dilute base is used, but I am asking the characteristic of a compound. Which kind of requirement it need? Yes, contain alpha hydrogen. Very good, very good. Yes, it's require alpha hydrogen, right? Then and then it will undergo aldol condensation reaction. Okay, it is very important. There are some more reactions, but it is not important from this side. Okay, but there are also some many other reaction which there is a prerequisite of alpha hydrogen. Okay, alpha hydrogen is a prerequisite for the aldol condensation. So it will be more feasibly given by the ketones which contains alpha carbon. And what do you mean by alpha carbon? I think you guys know that, right? What is the alpha carbon? Alpha carbon, what is alpha carbon? Which carbon we can tell as alpha carbon in an organic compound? Fast guys, then we have to cover the heterocyclic compound also. Carbon adjacent to functional group. Very good, Bhargava. Very good, very good. Why I am asking you guys these things? Because the basics are very important. As much as you revise your basics, you clear your fundamentals, revise it more and more, it will be more beneficial for you in the final exam. Okay. Directly bonded to functional group. Yes, very good, very good. Yes. So that is the definition for that. Now here, there is some difference between aldol condensation and reaction. Okay, you guys might use it very frequently or very interchangeably, but they are not same. Aldol reaction and aldol condensation, they both are different. Okay, so let's read this also. Sometimes they are asking you for a product and they have written that according to aldol reaction or according to aldol condensation, and they definitely gives you both option to trick you, but you have to read whether it's aldol reaction or aldol condensation. Okay, here the, for example, we have taken the example of ketone, that is acetone, okay, or propan-2 according to IUPAC name. So here it is acetone. When and as someone has told in the chat box that dilute base is required, you are right. Yes, dilute base like NOH, but it's a dilute. It means the somewhat lower concentration, NaOH. Okay, so when this will react in present, and here one more thing, that it will require two molecules. Okay, two molecules of a ketone, particularly here in this case we have an example of acetone. When they will react, so this will first form a carboanion. Okay, it will form carboanion. Okay, it will forms a carboanion, and that carboanion, then will attack on the second remaining, because we have a two you can say molecules of a propanol or acetone. Okay, so first one will form a CH3, or you can say CH2 minus, one hydrogen will be removed. Okay, so this is the first one, and on the second one, what happens, that as this double bond electron, one bond electron will be taken up by this oxygen of carbonyl compound, carbonyl group. Okay, and this CH2 minus will attack here. Okay, and after that the hydrogen which is removed, it will attach on this you can say oxygen, and this intermediate beta hydroxy ketone, this will be formed. Okay, I want to know one thing. In which in biochemistry there is a one biochemical reaction where beta hydroxy ketone is formed? Can you name that, guys? Where the beta hydroxy ketone is formed? Remember that whatever will be connected, interconnected in the subjects, I will ask the question from that part also. So it will be somewhat more easy for you to revise the things simultaneously. Do you know, guys? Okay, okay. There is a beta hydroxy ketone is formed. If you try to recall, beta oxidation of fatty acid. Do you know, guys, beta oxidation of fatty acids? Okay, read that. You will find this compound, beta hydroxy ketone. Its acyl form will be there. Definitely, it's attached with the acyl group, acyl CoA enzyme. So that's why its acyl form will be there. Okay, so try to revise in that way also. Try to connect the subjects. So and try to revise simultaneously where the some connection between the subjects are there. Try to revise that also. It will help you more and more. Okay. So move to next things. Next thing, this up to this step. Okay, up to this step where the OH is formed in this compound, right? The intermediate which is contain hydroxyl group. As I have explained you the mechanism here, the first step. So this one is aldol reaction. Okay, this one is aldol reaction. When from this aldol reaction, when water is get removed, see here, there will be a one hydrogen here, right? There will be one hydrogen here, right? So from one hydrogen, this and this OH, This will get removed in the form of H2O, and then it will form a final product, alpha beta unsaturated ketone or alpha beta unsaturated carbonyl compound in general. If you use aldehyde or ketone, one of each, one of them. Okay. So this is what the difference between these two. Remember this. If anyone not able to get this, you can ask in chat box. Okay. I will try to explain it somewhat in short. Okay, but this is very important concept because they may ask you the product, because there is a question in previous year. They have asked you aldol reaction, not condensation. And definitely they will give you this both option, beta hydroxyketone and alpha beta unsaturated ketone. Okay, they will give you both option, but you have to select accordingly whether it's a reaction or a condensation, because condensation involve removal of a water or a ammonia or a alcohol. Okay, or a removal of a small molecule. That small molecule is water, ammonia or alcohol. So that is known as condensation. Okay, so try to understand in this way. It will be more helpful for you. Okay, so remember it, very important concept, because there were questions that they have asked you aldol reaction, product for aldol reaction, not the condensation. And if it was the condensation, then it will form a alpha beta unsaturated carbonyl compound. Okay. Any question, anyone? If you are not able to get, you can ask. So now which reaction is this one? Fast guys, which reaction is this one? Fast guys, fast. We have discussed this about this reaction in one reaction in previous class. If you guys observe it properly. Which reaction is this one? Michael addition. Very good, Manisha. Very good. Very good. Only Manisha is answering about the naming reaction. All of you guys have tried to answer. At least try to answer. If your answer is wrong, no problem. You will learn something, right? And it will be more memorable for you, because or you can say remember it for a longer period, because you know that I have answered it wrong here. So it will be in you can say placed in your mind. So try to answer. Okay. So this reaction is Michael addition. Okay. So what happens in case of Michael addition? As I have told, this reaction is involved in the Robinson annulation also. The first step of the Robinson annulation is Michael addition. Okay. And this reaction will be shown by the carbonyl compound. And one more important thing, carbonyl compound, but you have to add here before it that it's a alpha beta unsaturated carbonyl compound. Okay. Alpha beta unsaturated. So the alpha beta unsaturated carbonyl compound will show this reaction, Michael addition. Any alpha beta unsaturated carbonyl compound. I am again repeating any. It can be aldehyde, it can be ester, it can be ketone. Okay, it can be carboxylic acid. Okay, in presence of strong base. So this one is your alpha beta unsaturated carbonyl compound. Actually, they have shown here it in reagent, but it will be in here. Okay, it will be in reactant. Okay, so this alpha beta unsaturated carbonyl compound will show this reaction. And what happens? In case of Michael addition, that this alpha beta unsaturated carbonyl compound will react with, what is the name of this compound? where the two oxygens and ester group is there. OET, first one, this group. What is the name of this group or this compound? Name of this compound? Anyone? Name of this compound? What is the name of that compound? This one. Name of this compound. Fast, guys, fast. Your IUPSC is also important, right? Because there are some very simple question from the IUPSC naming itself. They will ask you the name of IUPSC name of a compound or a common name of a compound. So we'll try to cover every aspect which is connecting to our topic. Okay. So what will be the name of this compound? Common name. Anyone? Anyone? What is the name of this compound? Okay, I will tell. It's a ethyl acetoacetate. It's a ethyl acetoacetate. So when ethyl acetoacetate will react with alpha beta unsaturated carbonyl compound in presence of strong base, okay, so what happens that this ethyl acetoacetate simply will added here in place of this double bond. This ethyl acetoacetate here, it will contain one hydrogen, right? So that hydrogen will get removed, and that hydrogen is get removed. Sorry, not that here, not here, here. Okay, from here it will first generate the carboanion as I have explained in aldol condensation. Same one, it will first generate carboanion, and then will attack that carboanion will attack on this double bond. Okay, and on attacked on in this double bond, okay, and it will form this compound. So simply if you have observed, attack, it is attached here. See this round I have I am making on this part. If you simply observe, this part is of ethyl acetoacetate. Okay, and this one, the red portion is your alpha beta unsaturated carbonyl compound. Okay, so both are attached, and that's why it's a addition reaction. That's why we call it as a addition reaction. Okay, so ethyl acetate react with the alpha beta unsaturated carbonyl compound in presence of strong base. Okay, then it will give us a addition product. Okay, so that is what the Michael addition reaction is. And here written is H3O plus. This is because it is for the what I have told you again, that it's a form a carboanion. So from that carbon, the hydrogen removed in the you can say in the form of H plus. Okay, and the entire reaction will be in somewhat you can say some aqueous portion will be also there. So that H plus will be converted into H3O plus. That's why they have written H3O plus here. Okay, you simply H plus can be written here. Okay, and that H plus is come from the carboanion. As the carbon removes the hydrogen, and it will get negative charge. That is carboanion. Okay. Any question, anyone in this reaction? Anyone, any question? If you are not able to get, okay, very important reaction. This one is also very important. And one thing I want to ask, that in synthesis of which drug the Michael addition is used? Again, I am repeating, in synthesis of which drug Michael addition reaction is used? Fast, guys, fast. Last, I think, reaction is this one. Last one or two reaction. No, not salbutamol. Salbutamol, we have discussed MPV reduction, right? We have discussed MPV reduction. So, MPV reduction is used in case of salbutamol. Not salbutamol. I will give you a hint if you are guys are able to answer. It's a drug which you can say if you give it in a higher dose, it will cause a bleeding and a hemorrhage. Now, if you guys get answer, yes, warfarin, yes, very good. It's a warfarin. Okay, remember this. It is very important. Sometimes they will ask you the you can say synthesis part of the drugs that will also cover by somewhat Payam sir. But it is connecting here, so I am giving you insight of that. Okay, so Michael addition is used in the case of warfarin synthesis. If you see the synthesis of warfarin, the first step of warfarin synthesis is a Michael addition reaction. Okay, it involves the Michael addition reaction. Now, which reaction is this one? Which reaction is this one? Which reaction is this one?
परवीन आंटी का फोन होगा तू कर ला
Getterman coach. Okay, yes. Very good, very good. Yes, it's a Getterman coach reaction. Yes, very good, Vivek. Very good. And this was in this year GPAT as well as this year NIPER 2023, NIPER 2023 and GPAT 2023. This question was there in both of the examinations. Okay, in both of the examination in somewhat different way. Okay, in case of NIPER, they have asked something. They have asked about. I think they have asked about the. They have given the reaction and they have asked the name. And in case of GPAT, I think they have asked the final product. It means that they have given the reaction part, this part, and they have asked the what will be formed. So it will be Getterman coach. So it will form a benzaldehyde, right? Simply carbon monoxide will react with the benzene in presence of AuCl3 and also this and three compounds, that is carbon monoxide, HCl, and the benzene will react in presence of AlCl3. Okay. Also, there is a presence of cuprous chloride, right? It's not a cupric because copper in plus one state. So it's a cupric chloride. Okay. And it will form a benzaldehyde. So it's a Getterman-Koch reaction. There is a one more reaction for the synthesis of benzaldehyde. Can you name it, guys? And that was also in the NIPER 2023. In NIPER, not GPAT, can be asked in the GPAT 2023. This was in both, but the reaction I am asking, one more reaction for the synthesis of benzaldehyde. Which reaction is that one? Yes, etard. Yes, etard was also there, and one more is there. One more is there. One more. Can you name it? One more. PDBaSO4 as a used as a reagent. If you guys able to recall the name of reaction, PDBaSO4. Rosamond, yes, very good, Manisha, very good. Rosamond. It is also used for the synthesis of benzaldehyde. So remember this all, right? There will be a kind of a question that which of the following reaction is used for the synthesis of benzaldehyde, and they will give you the option like you can say Rosamond, then Getterman coach, okay, and then Itard, and there is all of above, or there is a name of two B and C, both this kind of options can be possible. So try to see every angle, okay, and that's why I'm asking that all name of all reaction which are used to synthesize benzaldehyde. Okay, and what is the importance of benzaldehyde? What is the importance of benzaldehyde? In which industry it is used? This question was also I have seen somewhere in GPAT question paper, but it's not in recent year, but it's in previous year question papers, somewhat long back. Benzaldehyde is widely used in the case of perfume industries, right? Remember this also. Widely used in case of perfume industries. Benzaldehyde. Okay. Now we will come to the topic. So which reaction is this one? Which reaction is this one? Sandmeyer. Is it Sandmeyer? Again, see Manisha, is it Sandmeyer? I have also, we have also solved the MCQ on this. See, again, see it. Whether it's a Sandmeyer or a Getterman coach. Sorry, Getterman, not a Getterman coach. It's Getterman. Whether it's a Getterman or a Sandmeyer. Yes, it's a Getterman. Why it's a Getterman, Vivek? Why it's Getterman? Why Getterman? Why Getterman? Because of, yes, this is CU only. It means it's talking about CU powder. And this question was in the GPAT 2023, as we have solved this question on the Getterman and Sandmeyer also, right? We have solved the question in previous class. So this reaction is a Getterman reaction. Okay, we are using CU powder. While in case of Sandmeyer, what we use? CuCl. Okay, so this is difference between Sandmeyer and Getterman. This is CU powder is for the Getterman. So this question was also from the GPAT 2023 May. This question was there. Okay. So this is about the naming reaction. I think there will be no more naming reactions. This is one more. Okay. This is last one. I think you guys are able to answer it. Which reaction is this one? The first one and the second one also. Both I want to know. Which reaction is this one and which reaction is this one? I just have diazotization. Yes, first one is diazotization. Yes. Diazotization. Yes, very good. And diazotization is used for the synthesis of what? Okay. There is one more application where diazotization is used for the synthesis of azo dyes, right? Azo dyes, if you know, guys. You know, guys, about azo dye? Coloring dyes. Okay. Where this diazotization reaction is used. Yes, diazonium salt, and then diazonium salt will use for the synthesis of azo dyes. Okay. So that is diazotization reaction. Very good. And the second one is Sandmeyer. Very good. Yes. Very good. So this is, guys, about the all the naming reactions. Okay. This is all about the naming reaction which I want to cover. Okay, this all are the important naming reaction. Okay, I have tried to cover every possible because I have gone through the previous somewhat long year back GPAT question papers and recent year GPAT question papers also. So I have, guys, I have we have solved the every possible questions from the recent year GPAT question paper, and there will be some questions in your mock test also. Okay, from this kind of naming reaction, there will be some twist in the mock test, in the this kind of MCQs. So you guys have to answer it very clearly. Okay, and try to read it properly and then answer. Okay, so we will now start with the heterocyclic compounds, some basic nomenclature of that, and then there is a naming reactions for the synthesis of heterocycles also. Okay, there is also some naming reaction, and that naming reactions are also important. Okay, so we will cover that. Okay, any question, anyone in this? So we can move on the part of heterocyclic compound.
थोड़ा ही ले श्रुति बर नको ले चाहिए तो वापस आके लेके जाएंगे
Okay, so now we'll start with, just a minute, guys. Is my screen visible to you guys? Is my screen visible to you guys? Just a minute, guys. Just a minute. Is my screen visible now? Is my screen visible? Okay, okay. Thank you, thank you, thank you. Okay, okay, okay. Okay. So what do you mean by heterocyclic compound, guys? What do you mean by heterocyclic compound? What do you mean by heterocyclic compound? What is heterocyclic other than carbon? Okay, okay, yes. What kind of heteroatom we can expect in the ring? What kind of heteroatom? Ring consists of heteroatom. Yes. What kind of heteroatom? Oxygen, nitrogen, oxygen, sulfur. Yes. Other than nitrogen, oxygen, sulfur, which kind of heteroatom? Other than nitrogen, oxygen, sulfur, there will be possibility of phosphorus. Yes, very good, Apurba. Yes, phosphorus. Then two more are there. Arsenic and one more is there. Can you name that? Arsenic and selenium, right? Arsenic and selenium. So there will be nitrogen, oxygen, sulfur, arsenic and selenium. Okay. Okay. So remember this all, not only on nitrogen, oxygen, sulfur. There will be a MCQ on this kind of very simple MCQ that they will ask you which kind of heteroatom is present in the heterocyclic compound. Which of the following? So they will give you all options and you will select just nitrogen, oxygen and sulfur only because of the reason that most of the organic compounds will contain nitrogen, oxygen and sulfur as a heteroatom. Okay. So remember this very basic concept but very important. So this is what we are talking about. As a X it is representing the heteroatom, but here also it can be arsenic or selenium. Okay, it can be arsenic or selenium and also the phosphorus. There is a one drug which contain phosphorus as a heteroatom, anti-cancer drug which contain phosphorus as a heteroatom. Can you name that, guys? Anti-cancer drug which contain phosphorus as a heteroatom. Can you name that, guys? Cyclophosphamide. Vivek, very good, very good. Cyclophosphamide, right? Very important. Very good, very good. Very good. In treatment of which disease cyclophosphamide is used? So this is all about the basic, you can say, heterocyclic compounds, right? We'll directly jump onto their nomenclatures because that is what somewhat more important part. Okay, and then we'll go for the naming reaction. Okay. In which disease, which cancer it is used? Cyclophosphamide. Can you name that? And one more extra use of cyclophosphamide is there. Why I'm asking these things? Because it is interconnected, right? So that's why I'm asking these things. So it will be somewhat very short revision of that other subjects also which are interconnected with this portion. Cyclophosphamide is used as a immunosuppressant also, if you have read it. Not a blood cancer, beta. It's I think drug of choice for the lung cancer, cyclophosphamide, right? And what is the antidote of cyclophosphamide? This question was in GPAT 2023. Yes, immunosuppressive is right, but what is the yes, Meshna, very good. This question was in the GPAT 2023. Okay, what is the antidote for the cyclophosphamide toxicity? Okay, and what is the full form of Meshna? IUPAC name of Meshna? It is a organic compound, right? So what is the IUPAC name of that? Sodium 2-mercaptoethane sulfonate, right? Sodium 2-mercaptoethane sulfonate or sodium 2-sulfonate mercaptoethane. You can tell it as vice versa, right? So it's a 2 sodium or sodium 2 sodium mercaptoethane sulfonate. Okay. So remember this. Okay. Full form of the Meshna. Now we'll move to our main topic. So this is the things which you have to remember, that what is the prefix for oxygen. Why I am giving the some basics about the heterocyclic nomenclature, because in GPAT 2021 there was a one question that they have give you a ring like this, and they have asked you the you can say heterocyclic, according to heterocyclic nomenclature, what will be the name of this compound. This question was in GPAT 2021. So that's why I'm covering this part, and not only limited to GPAT 2021. This was also in, I think, GPAT 2022. There is also one compound. And in previous year GPAT question paper before 2021. Okay, so there will be a chance at your time also. So what you have to remember is that when you see a oxygen in the heterocycle, so what will the prefix for that oxygen is oxa. Then for sulfur, it's a sulfa, or you can say thia. More commonly is the thia. And then the nitrogen, for nitrogen, it is aza. And for phosphorus, it is phospha. Okay. And for selenium, it is selena. Okay. So remember this. And this is the priority order if you see. So one more thing, when you write the name, okay, so what will be the priority order? In general, most of the compound given to you will be contain oxygen, sulfur and nitrogen only. So that for that priority order will be O, S, N. Okay. So first will be oxygen, then sulfur and then nitrogen. Like for example, one compound contain nitrogen and oxygen both, like for here. So first you have to mention the oxa, and then you have to mention the aza. Okay. So this kind of things you have to keep in mind. Okay, because they are asking some simple nomenclature of a compound. They are asking some simple nomenclature of a compound, and they will it will gives you 4 marks. Okay, very simple if you understand it. So you have to first remember this prefixes and also the order. Okay. Now one more thing, that do you guys know about that which kind of prefix will be used for which kind of ring? Do you know guys that? Do you guys know that? Okay, we will discuss. Okay, I think you guys might not know. We'll discuss it with some examples, so you will get more idea. Okay. First, you remember that I am returning order here. 3, 5, 6, 7. As we know, right? For a ring formation, minimum 3 uh, atoms will required. Okay. So for if a ring, heterocyclic ring contain 3 members, so it will be IR will be the you can say prefix. Okay, IR will be the prefix IR. Okay, this is prefix. Prefix means which comes before the you can say name. Okay, so it is prefix. So first for the three you can say the compound which contain three atoms, heterocyclic compound contain three atoms in a ring. This prefix will be IR, then it will be ET for 4-membered. For 5-membered, it will be all. For 6-membered, it will be in. For 7-membered, it will be EP. For 8-member, it will be OC. For 9-membered, it will be ON, and for 10-membered, it will be EC. So you can remember it like iritol, iritol, in, epoch, on, eclair. Okay, this is a mnemonic for the for remembering this. You can say the prefixes for different number of different rings. Okay, which contain different number of you can say atoms. Okay, so it's a iritol, in, epoch, on, eclair. So IR, ET for the 4-membered, 5-membered OL, 6-membered IN, 7-membered 7-membered EP, then 8-membered OC, 9-membered ON, and 10-membered EC. Okay, you are clear with this? Note it down if you don't know. Okay, and then we will now solve some MCQ. So it will give you more idea about the it will give you more understanding. We will solve one MCQ, that example which I have given you of GPAT 2021. Now we'll discuss its IUPAC name according to heterocyclic nomenclature. Okay. So this compound is that one. What will be the name of this one? If you guys get some idea. Okay. First one, I will give you under explanation. Okay. And then you guys have to answer, because this is very basic thing. You guys must have to must know this. Okay. So first, as I have discussed, it's presents oxa, right? So it will be oxa. Okay. Now, as I have told you that it's a what how many number of atoms present in a ring? How many number of atoms present in a ring? 4. Yes. So it will be ET, right? So first you have to write the name of the heteroatom in the form of prefix, which is oxa for the oxygen. Then 4 as the number of atom is 4, so we will write ET. And then as this ring is saturated, right? Have you seen any are you able to see any double bond? So it will be ANE. Yes, yes, Pavani, yes. So it will be ANE. If the ring is saturated, then there will be use suffix. I am repeating suffix of A. The suffix will be ANE. And for the unsaturated, it will be ENE if the double bond is present. Sorry, not ENE, INE. Okay. It will be INE. Okay. For the double bond, if double bond is present, so it will be INE. And this is for the saturated compound, which means that it doesn't contain any double bond, like this example, right? So we'll write it as a ANE. Now you have to combine this name. Okay, you have to combine this name, but as this oxa plus ET, both here before ET, oxa contain a one as you know the AEIOU, right? Okay, you know AEIOU, right? So very simple English you have to apply here. So you have to cut this A as same. I think we will we can do we are doing that in IUPAC also, if you guys know about basic about IUPAC. Okay, so it is from the AEIOU letter, so it will be cutted down. Okay, so and then if you combine this all letters, So it will, the name will be oxetane. Okay, oxetane. Similarly, if here it is ET, okay, but if in place of here this is also a letter from AEIOU, and if here in place of ET some there is other prefix and it contain AEIOU letter, then also you have to cut that down. I will take one example on that also. You will get more idea about that. Okay. So this is oxetane. Everybody clear? Okay. How I have given the name to this compound? First, you have to write the name of heteroatom. Then the how many number of atoms present in the heterocycle. According to that, I have give you the list of that prefix 3, 4, 5, 6, 7. According to that, you have to select. So here it is 4 membered. So we have select ET. And then as it is saturated. So as I have told, for saturated, we will use ANE. For unsaturated or double bond compound, if double bond is present in heterocycle, we will use of AEIOU letter. Just you have to cut it if the AEIOU letter is present before. You have to attach, you can say connect that all letters, and the name which is formed will be your name of the heterocycle. So this is how the naming of heterocycle will work. Okay, it is somewhat different from the IUPAC nomenclature of our you can say the normal organic compounds. Okay, anybody any doubt in this? Anybody any doubt? Anybody any doubt in this? So now I will give you one example. You have to answer. Okay, I will give you one example. You have to answer it. What will be the name of this compound? What will be the name? Try to answer fast. I-10, if nitrogen was not there, then Akshata, your answer is right. But if nitrogen is not present, here the nitrogen and sulfur both are present. So first, as I have told, for OSN you have to see. Okay. So before nitrogen, yes, thiazetane. Thiazetane, yes. So first, thia will be there. Then aza. And as we use INE, right, as double bond is present. Okay. As double bond is present. Okay. But one more thing. Now we will include one more rule. First, we have see about the prefixes of the heteroatom. Then we have seen the what prefix you have to use for the different number of atom present in the heterocycle. Okay. Then we have seen the rule of ANE and ENE, where to use ANE and where to use ENE. Now there is a one more thing that you have to remember, that when a heterocycle contain compound 4, 5 or 6 membered heterocycle. Okay, 4, 5 or 6 membered heterocycle contain double bond. Okay, when it contain double bond, I have written it as a DB. When it contain double bond, so you have to just add plus E as a suffix only, not INE, not INE. You have to just only add E only in case of only for the 4, 5, 6 membered, as this ring is of 4 member. Okay, so here I will not add INE. I will only add plus E. Only E I will add. Okay, only E I will add. So it will be thia plus aza plus E. Okay, and also it will be ET. And then in last it will be E, as it is 4-membered. So ET will be, we will use, okay, for 4-membered ring. So it will be, now we have to cut this one also, this and this one, as I have told you that from the previous letter we have to cut. If it is present AEIOU letter from the AEIOU is present, then you have to cut it. As here also letter from AEIOU, which is A, and in case of AZA also the letter from AEIOU, which is A, and here it is letter from the AEIOU, which is E. Okay, so it will be thia, thiazide. Yes, thiazide. Somewhat maybe name will be may not grammatically correct, but this is IUPAC nomenclature for the heterocyclics. So this is the correct name. Okay, thiazide. Okay, thiazide. Thiazide is a correct name. Yes, yes, Haripriya. Yes, you are right. Okay. Any question, guys? If you are not able to get anything, remember that point which I have told you, that it, in case of if it is 4, 5 or 6-membered ring and contain double bond, then you have to uh, uh, only add plus E. But remember, if double bond, if not double bond, then will be ANE is the normal way which we use. One more example we will take, and then we will move for the naming reactions. Okay, so you will get more idea somewhat. Sir, what about other than other one, 7 and 8? See, Shiana Mandan, there will be no question from that much big rings. Okay, because it will be somewhat more big to remember, and it will be somewhat more complex. So that kind of question mostly they will not give you, but we will discuss one drug. Okay, like for one drug example. Okay, so in last, so you will get idea, but we will discuss it in last. Okay, is it okay? We will discuss it in last. Okay, okay, okay. So one more example we will take, and then we'll move ahead. What will be the IUPAC name? I am not asking about common name. What will be the IUPAC name of this compound? IUPAC want I. I want IUPAC name. Common name everyone knows, it is pyrrole. But what will be the IUPAC name? Yes, azole. Vivek Karanjar. Very good, very good. Why? Because as I have discussed, first we have to write the name of heteroatom in form of prefix, which is aza. Then as it is 5-membered ring, so it will be OL. And as I have mentioned again that in case of 4, 5 or 6-membered ring containing double bond, we will only add E, not INE, only E. Okay, and we will remove this A, as it is from the AEIOU letter. Okay, and the preceding letter is also from the AEIOU, which is O. So that's why it will be azole. Okay, very good. This is very important. Okay. So remember the all the rules which I have told you. First is of the prefix used for the heteroatom. Then second one is the all the prefixes for the all the ring members, which is 3, 4, 5, 6, which suffix we will use. And then where we use ANE, where we use INE, where we use E only. Okay, so remember this, and also the OSN. Rule of OSN, where to give prefix to which heteroatom. Okay. Now we will move towards the naming reactions. Now the first synthesis reaction is Palnor synthesis. Okay. The first synthesis reaction is Palnor synthesis of pyrrole. This question has been asked in GPAT 2022. Okay. Okay. GPAT 2022 Palnor synthesis. First, we will discuss the all synthesis naming reaction for the pyrrole. Okay. So, we will discuss that some more reaction about pyrrole and other heterocycles also. Which other reactions are available to synthesize pyrrole? Which other naming reaction? Type your answer in chat box. So this reaction is Palnor synthesis of pyrrole. So first, acetyl acetone. Remember this names also. Acetyl acetone will react with ammonia in presence of ammonium sulfate. Okay. And via removal of two water molecule, it will gives me a pyrrole which is substituted with the two methyls. Okay. So it will gives me substituted pyrrole. When acetyl acetone react, this acetyl acetone or this starting material, sometimes it is known as 1,4-diketonic compound. Okay. So it will react with ammonia in presence of ammonium sulfate, 1,4-diketonic compound, and via removal of two water molecules, it will gives me a pyrrole. So this reaction is a Palnor synthesis of pyrrole, and this was in GPAT 2022. Okay. Now, which other reactions are there for the synthesis of pyrrole? You haven't answered my question, which I have asked you in the start of this reaction. Which other naming reactions? Nor synthesis. Yes, very good, Vivek. Hence pyrrole synthesis. Very good, Naga Ishwarya. Very good. Hence and nor synthesis. And one more is the pyrrole synthesis. So now we will see that reactions also. So this is the Hence synthesis of pyrrole. Now what happens in case of Hence synthesis of pyrrole? That beta ketoester. Remember the starting materials, okay? How you can remember this? You can remember this via multiple time practice and multiple MCQ solving will help you, okay? As you solve more number of MCQs on the heterocyclic compounds and also on the and also try to practice in your copy. Okay, pen and copy, you take one pen and copy and try to practice this reaction. Definitely you are able to remember. Okay, why I'm not giving any mnemonics for this? Because it will may create some confusion during the exam. So that's why rather than that, try to go with pen and copy and remember in that way. It will be more easy and it will be you are able to remember it for a long term. Okay, for a long time. Okay, so what happens in case of Hence synthesis of pyrrole? That beta ketoester will react with the alpha chloroketone. Here it is beta, written beta, but there is some correction. It will be alpha chloroketone. Okay. It will be alpha chloroketone. Okay. This alpha chloroketone will react with the beta ketoester in presence of ammonia. Okay. In presence of ammonia, and it will gives me a pyrrole, substituted pyrrole. Okay. It will gives me a substituted pyrrole. Or here you can also observe very simply that this part is of alpha halo ketone, which is here it is chlorine. So it will you can tell it as a alpha chloroketone also. And this is part of the beta ketoester in presence of ammonia. So you can see that how simply is get that both compound get attached and form a pyrrole. So see this part is of the beta that is alpha chloroketone. and this part is of the beta keto ester. Okay, this one, and this ammonia is attached here. The nitrogen from the ammonia is attached in between, and it forms the pyrrole. Okay, so this is the hand synthesis of pyrrole. Alpha beta ketoester will react with the alpha chloroketone or a alpha haloketone. Okay, and it will gives me a substituted pyrrole in presence of ammonia. Okay, in previous reaction, Nor synthesis, Palnor synthesis, there is also ammonia, but the starting material was different in that case. Okay, there is a starting material is what was the starting material in the Palnor? What was the starting material? I am also checking your presence in lecture, presence of mind in lecture. Acetyl acetone, yes, very good. Very good, very good. Now that is it, Nor synthesis, right? As we have discussed, three naming reactions are there for the synthesis of pyrrole, Palnor, Hans and Nor synthesis. So in case of what happens in case of Nor synthesis, do not try to remember the entire mechanisms. It will be somewhat more you can say complex for you guys. So don't try to remember the mechanism. Only try to remember the reaction. Okay, here it is shown the mechanism, but we will see only the reaction part. Okay, so what happens in case of Nor synthesis? Nor synthesis is very similar to Hand synthesis. What is the difference here is, here also we are using beta ketoester. If you have observed, this first compound is beta ketoester. Okay, the first compound is beta ketoester. And this beta ketoester will react with the here alpha amino ketone. In previous reaction, it was alpha haloketone or alpha chloroketone. Okay. Okay. So, and then it will directly, we can go here. So this alpha amino ketone and beta ketoester will react, okay, in presence of NaOH. Remember this also. In presence of NaOH, it will gives you a substituted pyrrole. Okay, don't go on this mechanism part. Just try to remember that beta ketoester will react with alpha amino ketone and it will gives you a pyrrole in presence of NaOH. Okay, in previous one, Hand synthesis, it was ammonia. Okay, and there is here it is alpha chloroketone. Here in this case, Nor synthesis, it is alpha amino ketone. Okay, is it clear? Is it clear? Any question, anyone? Till here? Any question? Any question, anyone? Okay. Now we'll move towards the furan. Okay, furan heterocycle. Furan is present in which drug? Do you have any idea in which drug furan is present? It's a diuretic drug. Now I will give you a hint that in a diuretic drug, the furan is present as a heterocycle. Furosemide, very good Haripriya, very good furosemide. Why I'm asking this? Because there is some questions they are asking on the which ring is present in which drug, which heterocycle present in which drug. And can you give me a name of amino acid which contain imidazole ring? Which amino acid contain imidazole ring? Histidine, very good Manisha. Histidine, yes, very good, very good. Okay, so whatever I am asking and whatever I am telling in during this all lectures, that all will be contained. Every sentence and everything I am speaking and I am teaching will be MCQ. Okay, it will be MCQ for you. Okay, and it can be asked as a MCQ. So Palnor synthesis, same Palnor synthesis for furan is also there for the for furan also. There is a Palnor synthesis where also we are using 1,4-diketone. But have you observed that in case of pyrrole, we are using ammonia here. Okay, in case of pyrrole, it was ammonia for the pyrrole. But in case of Palnor synthesis of the furan, we will use H plus, which is acid. Okay, HCl we will use. And we will use higher temperature. So it will gives me a furan. Okay, so that is the difference between Palnor synthesis of furan and pyrrole. There we use ammonia in case of pyrrole, and in case of furan we will use HCl. Okay, remember this also. Question can come from any part, and question has come. So this is the another representation of Palnor synthesis of furan, where they have mentioned the, or you can say combine one of for the, you can say why this slide I have put it because for this in case of Palnor, furan and thiophene, all of three for all of three the Palnor synthesis is used. Okay, why it is known as Palnor synthesis? Because of this 1,4-di ketone compound. Here also you can see 1,4-diketonic compound is there. Okay, so what is the difference between Palnor synthesis of all of these three rings? That in case of pyrrole, we are using this ammonia or amine as a base. In case of furan, we are using P2O5, or as I have mentioned, we can use HCl. Okay, or in case of thiophene, we are using P2S5. Okay, P2O5 is for the furan and P2S5 as it contains sulfur, so it will be for the thiophene. Okay, and HCl, P2O5 for furan, and ammonia or amine for the pyrrole. The name reaction is similar, but the reagents are different for synthesis of different rings. Okay, that is Palnor synthesis. Okay, so remember this also. In which antimicrobial drug the thiophene ring is present? Thiophene ring is present. In which antimicrobial? In which drug, antimicrobial drug, thiophene is present? Okay, you guys have to find it and you have to answer me. Okay, cefoxitin. Yes, 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 Akshata. Yes, very good, very good. Okay, now that was for the Palnor synthesis. Furan only synthesized by Palnor synthesis, and there is one more reaction, naming reaction for the synthesis of you can say furan. Can you name that? I haven't included because I want to ask you guys. Which naming reaction that one for furan? Phased bend resynthesis. Yes, yes, phased bend resynthesis. Yes, very good. Phased bend resynthesis. And if you know, in case of phased bend resynthesis, what we are going to use is beta ketoester. I'm talking about first phased bend resynthesis. Okay, that beta ketoester will react with alpha haloketone, but in presence of NaOH. It's very similar to hand synthesis, right? But in hand synthesis, we have used ammonia. Here we are using NaOH, and it will gives me a furan. And this reaction is known as phased binary synthesis. Okay. This reaction is known as phased binary synthesis. Do not get confused between Hans and this one, because in case of Hans synthesis, what we are using is ammonia. Here we are using NaOH. Okay. So there is only two naming reaction for the synthesis of furan, which is Palnor and phased binary. Okay. Naming reaction I am talking about. Okay. Naming reaction. Phased binary and Palnor. Okay. And for pyrrole, three naming reaction, which is Palnor, Nor, and Hans. Now we talk about the thiophene. So in case of thiophene, there is a Hinsberg synthesis of thiophene. In case of Hinsberg synthesis, we use ketone. And if I put OH here, OH, which I have written here OH, and here also in presence of this R, I have written OH, what will be the name of this compound? Common name of this compound? Okay, in place of both R3 and R4, where R3 and R4 has written, if I put OH, what will be the IUPAC name, or you can say common name of that compound? What will be the common name of that compound? What will be the common name? What will be the common name? It's a thioglycolic acid, right? Remember that. So we have used thioglycolate. Or you can use thioglycolic acid also. Okay. You can use thioglycolate or thioglycolic acid also. Both can be used. Here if R in place of R3 and R4, if there is a OH, there is no problem. That also can be used. That is thioglycolic acid. Okay. When thioglycolic acid or thioglycolate react with the ketone. Okay, this is ketone, right? When it react with the ketone, it will gives me a, in presence of base, it will gives me a simple substituted thiophene in presence of base. In presence of base, it will gives me thiophene. Okay, so this is the Hinsberg synthesis of thiophene. Very important reaction. Okay, try to note down everything, and if you have any question, you can ask in between in chat box. Okay, I am actively looking for your questions also. Okay, and for your answers also in chat box. Now we will go for the quinoline. So for quinoline, the first naming reaction for its synthesis is Fitzinger synthesis. Okay. And which other naming reactions are there for the synthesis of quinoline? Try to answer in chat box. Okay. I am explaining this. Yes, quark synthesis. Yes. One more. Friedländler. Yes. And one more is there. One more. Four are there. We have three with us. One more. One more naming reaction for synthesis of quinoline. Dobner-Miller. Yes, very good, very good. It's a Dobner-Miller, right? It's a Dobner-Miller. So it's a Dobner-Miller, right? So in case of Fitzinger synthesis, what happens that izatin, this starting material, this compound is known as izatin. If I remove oxygens, this both oxygen if I remove and I put a one double bond here, what will be the name of that ring? What will be the name of that ring? Indole. Yes, very good, very good. It's a indole, right? It's indole, right? Very good. So when this isatine react in presence of KOH, okay, it will simply gives me a 2-methyl quinoline, okay, or substituted quinoline in simple you can say. So you have to remember this isatine, KOH, okay, and also this compound. What is the name of this compound? What is the name of this compound? COCH3 twice. What is the name? It's very common. We have just take the example in aldol condensation also. See, I am checking you every every aspect. Dimethyl ketone. Yes, very good. Okay, be active in session so you will get more and more idea and more basic you learn, more number of question you can solve. Okay, because it's all about basics. If your basics are strong, you are able to solve difficult questions also. So isatine will react with the dimethyl ketone in presence of KOH and it will gives you quinoline. Okay, so that is Fitzinger synthesis. You have to remember isatine, ketone and KOH, which is very important. Okay, to identify the reaction. Okay, and again I am repeating, this all are the reactions from which the question has been come in previous year question papers. And someone has take the name of squab. Squab synthesis was in somewhere around GPAT 2020 and also 2018. And also in NIPER 2023, squab synthesis question from the squab synthesis was there. Okay, simply they have given the squab synthesis reaction and they have asked the name. Okay, or sometime they have asked the product. So product will be definitely quinoline. Okay. One more is the Friedländler, as someone has taken the name of Friedländler reaction. So in case of Friedländler, what we'll use is, in case of Friedländler reaction, we will use a aniline. Okay. And on this aniline, this second carbon, okay, on this aniline, the second position of the aniline is substituted with the aldehyde group or a ketone group. Okay, it will be aldehyde also and it can be ketone also. Okay, on aniline, and that will react with a ketone again. That will react with the ketone. Okay, and that will react with the ketone. Okay, and as a catalyst, what will be the catalyst here? Can anyone tell me? What will be the catalyst here? I have kept this for you guys so you can answer, because in this one, I haven't used that method which we have used for the naming reaction of general organic chemistry naming reaction. That I will click and then only the name of the reaction will come. What will be the catalyst here? What will be the catalyst? Base. Yes, very good, Vinay. Very good. Yes. Okay. So base will be catalyst here. Okay. Friedländler synthesis, base will be catalyst, or you can say as a reagent. Okay. And when the aniline substituted with the aldehyde or ketone on the second position react with the ketone in presence of base, it will gives me again quinoline. Okay, as this all reaction are for the synthesis of quinoline, it will gives me quinoline, and that reaction is Friedländler. First one is the Fitzinger, second one is the Friedländler. Then we have a Dobner-Miller. Okay. So this one is Dobner-Miller. Now, Dobner-Miller and the Schwab synthesis are very similar. Again, I am repeating, very similar. In case of Schwab synthesis, what we use is only aniline. In Dobner-Miller also we are using aniline. But the another starting material in case of Schwab synthesis is acrolein. Okay. This compound is known as acrolein, right? What will be the IUPAC name of this compound? CH2 double bond CH-CHO. Okay, and this will gives me quinoline. What will be the name of IUPAC name? As I have told you, the name, common name is acrolein. And this acrolein is also in the toxicity of one anti-cancer drug. Toxicity of one anti-cancer drug is also because of the formation of acrolein in that during the metabolism of that drug. Which anti-cancer drug is that one? Someone has answered it. And also I want to know the IUPAC name of this compound. Yes, it's a cyclophosphamide and the IUPAC name prop-2-enal. Yes, Vivek Karanjar. Why I am asking IUPAC name? I have told you the reason. There are some basic question based on the IUPAC name. Okay. So this reaction is of Schwab synthesis. Okay. Now in case of Dobner-Miller, here in Schwab we have used crotonaldehyde, right? We have used acrolein, right? In case of Dobner-Miller, we will use crotonaldehyde compound like this. Okay, compound like this we will use. Okay, and with the aniline. Aniline is common, but the other starting material which we have used is different. On that one is you can say acrolein. Here it is crotonaldehyde. Common name is crotonaldehyde. And the IUPAC name is but-2-enal. Okay, as that one is 3 carbon, previous one is of 3 carbon, this one is of 4 carbon. So this is but-2-enal as the double bond is on the second carbon. Okay, and it will gives you a quinoline. I'm not going on the mechanism. I'm going on the simple reaction. Okay, as mechanism may take more time for you. So I'm going on the simple reaction that you have to remember. Okay, mechanism, mostly they will not ask the mechanism. They will not ask the mechanism. Okay, so this is the Dobner-Miller synthesis. Now we'll see some synthesis for the isoquinoline. Can you tell me the name of the some reaction which are used to synthesize isoquinoline? Fast, guys. Now last 5 to 7 minutes. Okay, and then we will meet in next lecture. Okay, then we'll meet in next lecture. There will some more 3 to 4 naming reaction for the heterocycles that we can take in starting 5 minutes of next class. It will take only 5 to 7 minutes. But as this class is much longer, so you guys may get saturated with the so much naming reactions. So we will keep that 3 to 4 reactions in next lecture. Okay. So what will be for the isoquinoline? Isoquinoline will be last one. After that, we will see for the, I think for the imidazole and for the oxazole also. Okay, 2 to 3 naming reaction we will see. Anyone? For isoquinoline, you don't know? Okay, we will see this. Okay, yeah, we will see. So this one is Pomeranz synthesis for the quinoline. Okay, remember this one also. There was a question in NIPER. There is a one question in NIPER and there is one question in GPAT also. In GPAT, exactly, I think in 2017 or 2018. Okay, the name reaction question from the Pomeranz picked synthesis of isoquinoline. Uh, the question was there. Okay, in GPAT 2017 or 18. And there is also a question in NIPER. Okay. So what happens in case of Pomeranz synthesis of isoquinoline? As you know, guys, that there is a very slight difference between quinoline and isoquinoline, right? In case of quinoline, it contains the nitrogen on the second position. And in case of quinoline, there will be nitrogen on the first position, right? That is the difference. Okay. So in case of Pomeranz synthesis of quinoline, what happens? That aromatic aldehyde, okay, or a ketone, there will be you can take a reference compound benzaldehyde as a reference compound here. Okay, in place of R you can put hydrogen, or you can put any other R group. Okay, so here we have take benzaldehyde. So aromatic aldehyde or ketone as written here. So aromatic aldehyde and ketone, when it react with, this is very important, 2,2-dialkoxyethylamine. Okay, 2,2-dialkoxyethylamine react with the aromatic aldehyde or ketone and heated, and this mixture is heated. Okay, so after removal of water, it will gives me a isoquinoline. Okay, it will gives me a isoquinoline. And from this skiff base, there was a question in this year NIPER. Okay, not in GPAT, but in this year NIPER, there was a question from this skiff base. Okay, so remember this reaction, it is very important. Okay, and in GPAT, there was a question in 2017 or 2018, I think, around. Okay, from this name reaction of isoquinoline. Okay, there is a one glitch here in title. It is quinoline. Okay, it's isoquinoline. It's by mistake. It's a isoquinoline. Okay. Any question? Anyone till? Any question? Is it clear everything? Is it clear, or any question if you have, you can ask in the chat box. Okay. If you have any question, you can ask. Any question? Now this is the last naming reaction for today's lecture. Okay. And there is some more 3 to 4 naming reaction for other heterocycles that we will cover, and then we will cover in next lecture. Okay, and after that organic portion from my side will be completed, and then we will move forward for the industrial pharmacy portion. Okay, then I will start with some portion of Shutics. Okay. So the last naming reaction is a pictet synthesis for the isoquinoline. Previous one was the Pomeranz synthesis. This one is the pictet synthesis. Okay. So in case of pictet synthesis, when the beta phenyl ethylamine, remember the starting material name. Again, I am repeating in every reaction. Remember these names. Okay. And you are able to remember definitely by writing it. Okay, by solving the number of MCQs, more number of MCQs, definitely you are able to remember. Okay, so when beta phenyl ethylamine, okay, react with the acetyl chloride, okay, this compound is known as acetyl chloride, right? This compound is known as acetyl chloride. Okay, in presence of P2O5. Okay, and also in presence of PD. This reaction has 3 steps. First one is with the CH3COCl. In second step, we add P2O5, and in third step, we add palladium. Okay. So this all these three reagents are very important. Okay. And then it will finally gives me a isoquinoline. Okay. So in case of pictet synthesis, what you have to remember is beta phenyl ethylamine react with acetyl chloride in presence of P2O5, and in next step in presence of palladium, it will gives me a isoquinoline. Okay, so this is the pictet splengral isoquinoline synthesis, or commonly it is known as pictet synthesis. Okay, commonly it is known as pictet synthesis of isoquinoline, and the entire name is pictet spengular isoquinoline synthesis. So this is for today. Any question? Any question, guys? Any question, guys? This is for today. Okay. There is more 3 to 4 naming reaction is there, but I am not covering it in this lecture because it will be somewhat more more, you can say, number of many number of reactions already we have covered, so you will may get confused. So try to practice this all reactions, all reactions, and also the cover things we have which I have covered, SN1, SN2. Okay. And also we see some MCQs on this heterocyclic reactions. I have already told you in between. This was asked in this year, this was asked in this year, but still we will see some MCQs also. Okay. Already I have told you, but we will see some MCQs on that also. And also one last question. In which antimicrobial drug the quinoline ring is present? Very simple question I have asked you, because this question was in NIPER 2023, that isoquinoline is present in which of the following antimicrobial agent. This is for today, and this is the last question for today's session. Answer it. In which antibiotic quinoline is present? Very simple, guys. Try to recall. Ciprofloxacin. In general, fluoroquinolones. Okay, yes, very good. Ciprofloxacin is right. But the more perfect answer will be fluoroquinolones, because it cover all the drugs covered, right? Ciprofloxacin, ofloxacin, lomifloxacin. That all drugs contain the quinoline ring. Okay. So remember this also. Why I am telling this? Because they are also used to ask you question like this, that in which drug which heterocycle is present. Okay. So this is for today. If you have any question, you can ask. Otherwise, we will end up the session here. Do you guys have any question? Otherwise, we will end the session. And if you are having question after this session, after watching this session again, you can ask it in next lecture. We will see some more 3 to 4 naming reactions, and also the some MCQs, few MCQs on that. I have already covered many MCQs during the session. I have told you this question, this question, this question, but still we will see that. And then we will move for the Shutics part, and I will take the tablet chapter. Okay. From the industrial pharmacy portion, I will start with the tablet chapter in next lecture after solving MCQs of heterocyclic compounds, and also some remaining 3 to 4 naming reaction. Okay. So thank you so much for joining, and thank you so much for your patientful listening. And I apologize for somewhat delay in starting the lecture, and in between somewhat my mouse was lagging. So there will be may some handwriting problem. You are may not able to read the spelling properly, but then it was solved. Okay. Thank you for the session. Have a great day. Thank you. Thank you. Have a great day.